This is lesson 10.2, your second shape in our conics section. Today we're talking about parabolas. And in our conics, this is probably the one that has some of the weirdest features in its equations and in its graphing. So there's going to be a lot of information in this lesson. I'm going to try to move fairly quickly, and you can pause it as need be. So whereas yesterday we talked about circles and how circles are equally distant from their center, every point on the circle is equally distant from the center, the parabola, on the other hand, is focused on something called the focus and something called the directrix. Every point on a parabola is equally distant. So if you dropped a line down to the directrix, that distance would be equal to the distance of that point to the focus. Even if you have a smaller point, let's say over here, the distance to the focus and the distance to the directrix are still equivalent. And then, of course, the vertex is also equally distant from the focus to the directrix. And that one is the shortest distance. So it's kind of like watching spider's legs, is what I kind of think of it, is that if you were to draw any point here, these distances of these spider's legs are equivalent distances. So already you've seen two words that are different, the directrix and the focus. So those 2 points. And then the distance between them, these red distances you see here, that is something we call C. So that is your C distance. That'll be important for us today. The vertex is something that you're already familiar with. That is the lowest or highest point of your parabola. And then the axis of symmetry, remember, is that line which cuts the parabola in half. And any point on one side of that axis will be reflected to the other side of that axis. So they are symmetrical about that axis of symmetry here. All right, so let's talk about formulas. When we have parabolas that can open up and down. And when you have parabolas that open up, for easiness sake right now, let's just say we are focused at the vertex of 0, 0. When this is true, then you have parabolas that open up equal 1 over 4c x squared. And if they open down, it's y equals negative 1 over 4c x squared. So this negative is your main difference in the opening down part here. This c value, which again is being mentioned again, represents the distance from the vertex to the focus. Distance from the vertex to the focus. So this is actually a really key idea. This is going to come up whenever we graph and whenever we write equations. So let's talk about this basic shape here. Let's try to identify some of these pieces. Vertex in our picture here is at 0, 0. Axis of symmetry is whatever cuts the parabola in half, and it will also always run straight through your vertex. So for us, it's heading up and down, which means that it's an x equals, and it's going through 0, so x equals 0. The focus is not actually labeled on our graph here, so we're going to skip that. We'll move on down to the directrix. The directrix is labeled. It's this line here, negative 1. So y equals negative 1. What it does tell us, remember that c value we just said? It's an equally distant from focus to vertex. So if it's the distance from the vertex to the focus, it has to be the same distance from the vertex to the directrix. So since this distance is a distance of 1, this must also be a distance of 1. So our focus is going to land right there, and our focus will be the point 0, 1 because of the c value. We also have parabolas that go side to side. So again, for easiness sake, let's say the vertex is at 0, 0. If it opens to the right, it's x equals 1 over 4c y squared. And to the left is x equals negative 1 over 4c y squared. So your difference here is that for parabolas from side to side, left and right, x is on the end of the equation. X equals, not y equals. That's going to be your main way that you tell the difference. So here's our example. Our vertex, the highest or lowest point of the parabola right in here, so it's at 0, 0. Axis of symmetry, what it's reflected about, So there's our axis of symmetry running through. It is along the x-axis, so it's y equals 0. Focus is given for us here. Focus is given as -2, 0. Directrix is not, but again, we know the c value. C value here is -2 because it's vertex to focus. Vertex to focus is -2 units, which means it has to be the same units in the other direction for the directrix. So there's our directrix running here, which means that it is at x equals +2. Now this is an example you really want to star because this is going to come up in your homework and in your group work in class. Whenever you do these, it says write in standard form the equation of the parabola. Make sure that you sketch the graph first so that you can get an idea of up, down, left, right. And once you sketch, you're going to need your vertex and you're going to need your c value. Those are the two pieces you have to have in order to write a standard form of the equation. We're not given that. We're given the focus, and this line here represents the directrix. We're given these two pieces. From those, we can find these two after we do our sketch. So for this first one here, for example, my sketch, focus is at 1, 0. So there's my focus. Directrix is at -1. And we know that the vertex is equally distant between the two. So my vertex will be falling right here, halfway at 0, 0. So vertex 0, 0. And then the c value is the distance from the vertex to the focus. That's a distance of 1 unit. So that's c. c equals 1. In terms of our parabola here, opening left, down, or left, right, or up, down, you cannot cross your directrix. So your parabola will always swing out and come around the focus point. It cannot cross the directrix because, again, each of these points here is equally distant from the directrix and the focus. That's our definition. Every point equally distant. So it swings around that. So because it's opening left, right, we're going to need one of the x equals formulas. Since it is opening to the right, we're going to use the positive value. And our vertex is at 0, 0, so we can use that nice basic formula. Our c value then gets plugged in. Since it's just 1, it's 4 times 1. So x equals 1/4 y squared. For our next one, again, draw a sketch. Y equals 3 is the directrix. And focus is at -3, 0, -3 down here. And that means our vertex must fall halfway in between them. So vertex will be 0, 0. And our c value, coming from the vertex to the focus, is -3 because we're heading downwards. Since this is an up-down parabola, we're going to be using a y equals, and it's going to be a -1/4c x squared. Vertex is 0, 0, so we get to use this nice form here. And that c value, -3, means that here's the 3, 4 times 3. The negative is already included with our formula. The formula already has the negative that we need, telling us we're facing downwards. So this will be y equals -1/12 x squared. All right. What about graphing? A couple of things about graphing. First of all, we have to make sure that we highlight this, your equation into standard form, which means the variable without the squared should be by itself. So for example, it should be y equals or x equals. That's what we're trying to get at. Y equals or x equals. When you are trying to solve, sometimes you'll come across something that looks like this. And remember that that's the same thing as pulling the 20 out in front as a fraction, saying 1/20 x squared. We're going to prefer this one because it allows us to see that 1/4c better in this format. We're going to have to do a couple things. We're going to make sure that we identify the vertex. We're going to identify the axis of symmetry. We're going to have to find that c value, and that gives us the focus and the directrix. After that, to draw the parabola, we can either do a rough sketch or we can do a table of values for this. So here's our first two examples. Identify the vertex, axis of symmetry, focus, and directrix. Sketch the graph. First of all, we need to isolate the x, the non-squared term. So we're going to divide both sides by -4, which will give us -1/4 y squared equals x as our standard form. Our vertex, since it's in that format, same as before, vertex will be 0, 0. Axis of symmetry, hard for me to see that when I'm looking at this picture, so I'll skip that, I'll wait on it. And for my focus and my directrix, I need to know what my c value is. So let's focus on that. Grab your -1/4 here. So -1/4, that's equivalent to the 1/4c portion of your equation. Remember that your equation says x equals 1/4c y squared, so we're comparing 1/4c with -1/4. We're trying to figure out what value of c. Now you might just look at it and say, oh, c needs to be -1, and you're right. If you can't see it immediately, you could always cross multiply, so -4c equals 4. Divide both sides by -4 and you will get c equals a -1. So on our graph, we'll go ahead and we'll plot the vertex, 0, 0. The focus will be -1 units away, and since it's an x equals, we're going left to right, so focus will be back here. There's our focus, which means that it's at -1, 0. The directrix is 1 unit in the other direction, so up and down. Here's our directrix, which means it's x equals 1. And now we can see the axis of symmetry. The parabola cannot cross the directrix. It must swing around the focus, like this, which means that the axis of symmetry is running perpendicular to the directrix. This is going to be y equals 0. All right, second one. Same thing. We have to isolate the y. So we'll divide both sides by 8, which gives us 1/8 x squared equals y. Because it's y equals, this one will be opening up down instead of side to side. Vertex is still going to be 0, 0. There's no other points around here. Let's find our c value again. So 1/8. Take 1/8 and set that equal to 1/4c. This implies that c must be 2. So as we plot our vertex, 0, 0, 2 units up, since they were up down, to get to the focus, and 2 units in the other direction to get to our directrix. The parabola will swing around the focus, which then gives us the axis of symmetry as well. So axis of symmetry is x equals 0. Focus landed at 0, 2, my bad, right here. And the directrix was at y equals -2. So far, all of these graphs have been vertex 0, 0, and the equations have looked pretty simple, but they're not always centered at vertex of 0, 0. Sometimes they have vertex at h, k. So for us, we're going to have up-down parabolas with the y equals here. It's 1/4c as before, but here's the h and here's the k. Notice that the h is opposite of what we think it should be, and the k is just positive, whatever it is. If it's an x equals, then it's a left-right. And same thing, that you have your h and your k, but notice the h is on the outside here, and the k is on the inside because the k is next to the y, h's are next to x. So these are up-downs, left-rights at different vertices. So for example, this one here, we still would like to get the y by itself so that we can get it to look like this format. It'll be an up-down one. We're going to divide by 8, which will give us 1/8 x minus 3 squared. That would equal y plus 2. We're going to go ahead and subtract the 2 over, so we get y equals. So now we look like the up-down format here, and we see that the vertex is at +3, because again it's opposite the h, and then -2. Keep the k, whatever the k is here. Axis of symmetry, again, all that, we'll find that in a second. We need to figure out what c is, so we're going to take the 1/8. We're going to say 1 over 8 equals 1 over 4c. This implies that c is 2. So on our graph, +3, -2 for your vertex. It's up, down, and c is +2, so that means go up 2 to the focus. And then in the other direction, same distance for the directrix. The parabola will swing around the focus point, and then the axis of symmetry runs through the vertex. That's its symmetrical line there, always. So axis of symmetry will be x equals 3. The focus is at 3, 0, and the directrix is at y equals -4. All right, another example. So here we have, again, we need to get the y by itself. We're going to divide by -12 on both sides. And so we will have -1/12 x plus 2 squared. Move the 4 over, so +4 equals y. That's our standard form. Vertex, -2, because it's opposite whatever this is, and then +4, because it stays the same. And then c value, well, -1/12 equals 1 over 4c. c must be a -3. So -2, 4. We are opening up, down because of the y. So focus is going to move 1, 2, 3 units down, -3. 3 units in the other direction for the directrix. The directrix will be at 1, 2, 3, 4, 5, 6, y equals 7. Focus will be at -2, 1. And then the parabola will open downwards, and the axis of symmetry will run this way, so axis of symmetry is at x equals -2. Now this next example that we see here, it's the x that is not squared. So this one's going to open left and right. We still need to divide by 4. So we will have 1/4 y minus 2 squared. Let's move the 3 over, equals x as our standard form. In this case, the vertex, it's going to be kind of tricky. The vertex is the x value, so that's at the back here, +3, and then the opposite, because it's inside the parentheses, of the y value, so +2. You might want to put a star next to this one, that it's kind of different because it's that second formula. To find our c value, we'll say 1/4 equals 1 over 4c, so c must be 1. Vertex at 3, 2. We're going side to side, and it's positive, so go to the right 1 unit for your focus, 1 unit in the other direction for your directrix. Your parabola will swing out and around this piece here, and then your axis of symmetry will run horizontal. So axis of symmetry will be y equals 2, focus will be 1, 2, 3, 4, 2, and directrix will be at x equals 2. Now, in terms of figuring out what the different shapes are, we talked about in our last lesson how you can tell whether something is a circle or not by looking at the equation. And for these here, remember a circle has to have an x squared and a y squared term. They're both positive, and they both have coefficients of equal to 1. When you're dealing with a parabola, all that matters is that you have one squared term, doesn't matter, and it doesn't matter whether it's positive or whether there's numbers or whatever, just that there's one squared term. So it's actually a little simpler. As we look at our first one here, we have an x squared and a y squared. They both have coefficients of 1, and they're both positive, so it's a circle. So x squared and y squared is the part that we're looking at. On the second one, there's a 3, so it cannot be a circle, and there's a y squared, so it cannot be a parabola. So we'll say it's a neither. We'll say x squared has coefficient of 3. And then on our next one here, there is only one y squared term. So that's your parabola. All right, so that's your intro to parabolas.